Hello friends, let's discuss about our second approach that we discussed last time. We are going to use priority queue instead of linked list and see that how it works. So I created a new class order book using priority queue PQ and which implements our interface. In interface we have got these methods to add order, print level 1 and all print order book, cancellation and amendments, which we already discussed before. So just for the priority queue, if I compare this with our previous order book using linked list, right? So only thing that I'm going to change is that for the buy orders and for sell orders, in previously we were using linked list, and whenever you are trying to add any order, then we have to sort it using our comparator. So it was taking O and login. Now here the only difference is that when I use a priority queue, as I mentioned that for the sell orders we would be using Min-Heap, and for buy orders it would be Max-Heap. And in Java implementation of PriorityQueue class, by default it's always a Min-Heap. So here I just create our priority queue with this comparator being that based on price time priority, which means that price will get the first priority. After that, I mean, if there are two orders of the same price, the order which came earlier, that would be having a higher priority. So that's why we will be also comparing the entry time. Similarly, for buy orders, we are just going to, because it's a Max-Heap, that's why we have to reverse the priority, and then we have to compare the entry time. Entry time should be always same. I mean, it should be always the order which is coming first, it should be having higher priority. So this is the only difference between our linked list implementation and our new priority queue implementation, that we are going to use priority queue for both buy orders and sell orders. And the other of the logics are exactly same. Just quickly revise it. So whenever any order is received, first of all, we will see that whether the order has already been is being received for the first time based on the order ID, because order ID is the unique thing. We can only use the order ID to cancel the previous order or amend the previous order. But for adding a new order, it should be always the first time we are seeing this order, which is maintaining our order cache. So first we receive the order. Before adding it to the order book, we have to see whether the order can be matched with the existing orders in the order book or not. That's why we do the matching orders first. And only when the order is like completely filled, or if it's partially filled means that there are still some remaining quantity left, and there is no other order left in the order book to be matched, only then we are going to add it to the order book. And once we add it to the order book, as we have seen that it's a priority queue, it will only take O log n. This is where the difference is. For the linked list, it was taking when we add it, always we used to add it to the end, and then we have to compare it. Sort it. So that's why it was taking O and log n. But for priority queue, this is what the improvement makes the whole difference. That when you are adding it, it's only going to take O log n. Now for the matching orders, it's exactly same. If I compare this with order using linked list, again, let's revise this, that for priority queue, we are going to see whether there is an opposite order or not. For example, if we receive a buy order, we have to see that there are sell orders in the order book or not. Only then we can match it, right? So this is what we're doing. Once we get the opposite order, and then when we find that the buy order price should be always greater than or equal to the sell order from the opposite side, only then it could be matched, right? Similarly, if we have received a new sell order, then we have to match whether the sell order price is less than or equal to the existing best buy order price. This is how the matching happens. This is what all we have discussed in details when we are implementing the linked list for matching orders. So exactly same. The only difference is that now we are using priority queue. So based on this condition, if we have got a match, only then in that case only it will go inside this loop, and then we will get this opposite order. And as we have seen that for the linked list, the peak is always O1. Then we get the fill quantity, and then we match it. And then after matching it, we have to reduce that quantity, and then again we have to see whether there are remaining orders left in the order book to be matched. But here comes the main difference between the linked list. Suppose we actually we exhausted one order. For example, I got a buy order of say 100 or say maybe 200. Okay, and then on the opposite side, we have got a matching order for sell, which is of quantity 100. So only the buy order of 100 quantity would be matched with that sell order, and that sell order has already exhausted all its quantity. Now it has to be removed from the sell order book, right? And that's where when we pull it out, when you remove it, it will take O log n. And then again, for the buy order, the remaining quantity was 100 left because 100 was matched with the sell order before. Again, it will go to the same loop. Again, if it finds another sell order which is having quantity of like say 50, then 50 would be matched, and again it has to be removed after the matching, right? So that's where this O log n is going to take time. For the linked list, this was the slight improvement that we discussed, that because whenever we are going to remove it, it is only going to take O1 of the time. That's why the overall complexity, because it's a while loop here, it's going to be On, and here inside this, it's only going to be like O1. So it is the overall complexity for matching an order using linked list is always O of n because of this while loop. But this is not contributing anything to it, so it's always On. But for priority queue right now, we are in the same logic. We have got On for because of the while loop, and after that we always we are also removing it, which takes O log n. So that's why the overall complexity is O of n log n, and multiplied by O n log n, right? So that's what I mentioned in the previous video as well, that whenever we're using linked list, whenever you're trying to add any order, it is going to take O n log n, but for priority queue it's O log n. But for matching, as we just discussed, it is going to take O n for linked list, but O n log n for priority queue. Because this is while loop, and then we have got this log n whenever you want to poll on the opposite matching orders. So just based on this logic, let's test our priority queue implementation for matching the orders. So it's very similar to our linked list test. So I'm creating an order book, and then I will create an order book, something like this, in which we have got three sell orders with the best priority order at 20.25, and the three buy orders similarly for with the best order at 20.20. So after this setup method, it will be done. Now for that order matching, once this order book is created with three sell orders and three buy orders, I'm going to send a new buy order of say 250 at 20.35, right? So if I'm sending at 20.35, it means that our 20.35 would be much greater than even the worst sell order price of 20.30. That's why it's all should be matched. The only thing is that only the first 200 orders would be matched first, and 50 orders would be matched for this quantity, for this order number 3, because our buy order would be exhausted by then. So after filling, it should look like this. Only for the sell order, only like 150 would be left. So that's why this would be order book after once we send our buy order of 250 at 20.35. This is what we are doing here, and then we will have some assertions that after this is completely exhausted, then we will see that what is the sell order quantity of we already saw that it should be 150, and so after this 150, and the price should be 20.30. This we are going to assert it. Now let's run this and see. So I've just run this. So once we do the setup method, we can see our current order book is exactly same as 3 sell orders and 3 buy orders, exactly same as this one. And once we send our buy order of 250 at 20.35, then we can see that first of all, the buy order of say 100 at 20.25 got matched, which we are talking about this one. First of all, this got matched. Let me actually mark it here. First of all, this was matched. Okay. And then let me revert all of these previous ones. Okay. First, this was matched of 100 of 20.25, as you can see here. 100 of 2.25. After that would be 100 of 20.30, and only 50 quantity would be left. That would be matched with 20.30. So let me again revert it. So once I actually match completely, then as you have seen that after that only one sell order would be remaining with price of 20.3 and quantity of 150, which we have also asserted here. So after this, it would be this one as expected, 150 or 20.30. So guys, that's it for this video, in which we discussed about the priority queue adding of the order, which is n, which is only log n, and for matching it's n log n. So as we discussed this, we discussed 2 of them, add and match. In the next video, we'll discuss about how to display the price level 1, cancellation, and amendments of quantity. So stay tuned. See you all in the next video.